Hello students, welcome to the Yupp Master Foundation program. Today we are going to build a very important topic, that is advanced model problems based on the units and dimensional formulae analysis. So which is very important for competitive examinations, right? Let's see. Yeah, advanced model problems based on units and dimensional formulae. Just we have to see this one, right? You are taking that. Yeah, we would like to talk about that atom. This is atom. Let's see. It's going to be revolving around its nucleus, right? So you can take that. Yeah, you are going to take that. So radius, you know very well about that. The radius of the orbit, it can be identified. It's going to be nucleus. All right. Now if you are taking that, the radius of the orbit can be expressed in terms of angstrom units. It's very clear. If you are going to take that nucleus, the nucleons and their cross section area can be expressed in terms of Born. That is, if you are going to take that, yeah, this is very clear, cross section area, right? It is measured with Born, that is 10 to the power of minus 28 meter square. Just you will get this one. If you are identifying that the microscopic particles are going to be revolving in its orbit and they will possess the angular momentum, right? So let's see the problems associated with this one. Do you know electron volt is the unit of, just we have to take this one. Yeah. So if you are taking that, electron is revolving, it's revolving in its path, right? Suppose if you are going to take that, this is the second one, right? So you can take this one. If this electron is going to excite from first orbit to second orbit, is going to be here, let us assume. So it needs some amount of energy. Yes. So in order to jump from one orbit to another orbit, electron requires energy. Energy. It's very clear. At the same time, if you are going to jump, if you are going to observe that the electron is going to de-excite from higher to lower, some amount of energy is released. It is very clear. You have learned all these topics. So higher energy level to the lower energy level, the electron is going to jump from higher energy level to lower energy level. So there exists a emission of energy, there exists a absorption of energy. So in order to continue, in order to maintain the stability in its orbit, sometimes it will loses its energy, sometimes it will gains energy. So the energy gained by the electron, it has been measured in electron volt. Electron volts EV. Or if you are going to take that one charge, just you have to take that this is a one charge, let's assume it's a charge. So work done is also energy, work done by the system is also energy. Just we have to listen. If it has been moved, yeah, so we need to take that the potential we need to know that the potential V is equal to W by Q. Yes, work done to potential is simply expressed as work done to displace the charge a unit distance. Potential is nothing but work done by the system or external force to move the charge, yes, of one unit distance. It is very clear. We are going to just while you are going to take that work done, it is nothing but energy required to displace the charge. So simply we are going to take that this potential, yeah, 1 EV it's equal to 1 Q into 1 volt. Just you have to take that. This is the energy, potential energy, that is the potential energy. Just you can easily identify this topic to get the problems. All right. So please take this one. Let's go for the problem. Yeah, electron volt is the unit of energy. It's very clear. Right. We are getting the topic, that is energy. Now you can take that. If you are identifying this, this is a light source. What do you mean about light? It is a form of wave. Simply billions of photons are emitted from the source. These photons are exhibiting the particle nature as well as the wave nature. Just you have to see. It's going to be in the form of wave. All right, it's very clear. Now while you are going to talk about that, this, yeah, please let's have see. Right, you have to take how it is going to be exhibit the wave nature. It is very clear. If you are going to take that light source, this is the source of light. All right, it is very clear. From its surface it is emitted. Yeah, you can see that. It is in the form of wave. All right, it's very clear. So light is a form of emitted. Light is emitted in the form of wave. All right. So it's very clear. We are going to take this one. It's very clear. Right. If you are going to take that, lambda is the wavelength. Yeah, lambda is the wavelength. Yeah, in the lower classes you have learned that about that wavelength and frequency. All these parameters are related to that wave mechanics, and if you are going to take that, nu is the frequency. It is very clear. While you are talking about that energy, yes, it's going to be n into h nu. Yes, it's very clear. So you have to take that. This is the concept, that is the total energy. Total energy can be expressed as n integral multiple of this h nu. It's very clear. What is h nu? One quanta. Just it is going to be fundamental term to represent the total. So n number of photons are there. Now you are going to take that n into this. Yeah, you can take this one. So h nu is that quanta of energy. It's known as quanta. Say it's a one fundamental to represent the energy. So how many? Let us assume n number of photons are there. They are going to be written as h nu. What is h? You have to know about that. H is the Planck's constant. Like that, you have to write down 1 h nu, 2 h nu, 3 h nu, 4 h nu. So it is going to be taken as n h nu. It is going to be n h nu. It is equal to n h nu. So nu is the frequency, h is the Planck's constant. It is very clear. Now you are going to take that. Yeah. At the same time, nu is equal to c by lambda. That is the frequency of photon. You are going to learn about that photon. This is the modern physics to understood that radiation emitted by a black body, radiation absorbed by a black body. This is very clear. After that, after the development of the Planck's quantum theory, the stability of atom can be explained successfully. You know, energy is going to be absorbed or released in the form of h nu. Just you have to get that. Energy taken by that particle, that is going to be h nu, nh nu. Just you have to take that. So let's go for the problems. Right. So if h is the Planck's constant and lambda is the wavelength. All right. Now, have you observed the previous animated video? You have seen that h nu, we are all talking about that Planck's quantum theory. That is the energy emitted or absorbed by a black body, just it is going to be taken as a h nu, nh nu. Okay, let's talk about this one. Yeah, you know very well about that h nu. That is you are going to take that h into c by lambda, because nu is equal to c by lambda. It's very clear. This is the first one. Let's assume this is the second one. Right. What about the dimensions of yes, you have to take that energy, that is equal to h nu, that is equal to h c by lambda. C is going to be 3 into 10 to the power of 8 meter per second. Speed of light, just we are going to get that speed of light. It's very clear. You have to know this. So, finally, you are going to conclude that, yeah, E is equal to h by lambda into C. Okay, let us see the options. What about that? Does it represent the momentum? Does it represent the moment of inertia or frequency or energy? You have to see that. This is the case we are going to take that energy. So, this is a modern physics you have to learn. At earlier stage you are supposed to learn all these topics which plays very important role to understand that modern physics and the stability of atom and the radiation emitted by a body. It's very clear, you have to know that. But in the associated problems they have given, you have to get these all points right. Let us go for one. Very simple, it is going to be one problem based on principle of homogeneity. Left hand side and right hand side both are going to be compared, both are going to be having same nature. If they are going to be same kind of quantity, physical quantity, then only it is possible to add. Right, you can take that problem. The velocity of a particle at a time t is given by v is equal to at plus b by t plus c, where a, b, c are constants. All right, the dimensions of a, b, c. If you are going to take that, what about dimensions? Yeah, the powers are, you can take that dimensions. You are going to take that. The powers of the fundamental quantities are raised to represent the derived quantity. All right, simply powers or just you have to get that powers, dimensions are going to be powers. So, are raised to represent the derived quantity. All right, it is very clear. I will give you the example, just you have to take that. This is the taken velocity. Yes, just you have to take that displacement by time. By time. If you are going to take that fundamental quantity for the displacement L, it is going to be represented in its symbol L by T. Now, you are going to take that L power 1 by T power 1, that is L power 1 T power minus 1. So, you have to take the dimensions of length is power, that is going to be identified this. This is the case, you have to get that. 1 is the dimension of length. All right, it is very clear, we have to get this topic and you can easily understand this dimension concept. The powers are going to be raised. In the general expression, we are going to take that Q is the derived quantity. It has been expressed as A power P, B power Q, C power R. So, these are all the dimensions, just we have to take this one. So, these are the dimensions, just we have to take that. What about A, B, C fundamental quantities? These are all fundamental quantities. It is very clear. These are all the fundamental quantities and their powers are going to be raised to a particular value, whether it is going to be positive or negative, okay, whatever it may be, just we have to take this one. Now, at the same time, you have to take this problem, right? We will accept that. Okay, what they have given, they have given an expression which is related to that velocity, all right. Right, you can take that V is equal to AT plus B by T plus C, it is very clear. We are going to take this one, V can be expressed as summation of these terms, right. Yeah, we have to apply that principle of homogeneity. Apply principle of homogeneity. In order to estimate the dimensions of A, dimensions of B, you have to apply principle of homogeneity. You have to apply the principle of homogeneity, it is very clear. Now you are going to take this one, that is left hand side and right hand side is going to be comparable. Dimensions of compared, they are going to be taken. So if it is going to be added, please take that A is equal to, yeah, you have to identify this. The dimensions of V, the dimensional formula is going to be considered. Just you have to, in order to get the dimensions, you need to write the dimensional formula. It's very clear. So this is of A, we can take, this is of B, yeah, A is equal to B plus C. So the dimensional formula of A, B are going to be same. At the same time, C also, they are going to be having that same kind of this one, all right. Now you can take this, right, that is you can individually equate that, right. Therefore V is equal to A T. Now you will take that L by T is equal to A T, since small t can be represented as the capital T. Therefore A is equal to L into T power minus 1. It is a one we have obtained, but we are going to solve this one, right. Okay, now you are going to take this one, yeah, if you are going to take that B by T plus C, they are going to be V, they are going to be comparable with this one. Now if you are going to take that, C is going to be added, yeah, C is added to T, C is equal to T, they are added. C and T are going to be having that same nature, then we are going to add this one, all right. Now you are going to take this one, just we have to get the answer. A is going to be LT minus 1 and C is going to be T, and you can identify this one, right. Yeah, you have to take this one, right. So while you are going to take that B by T is equal to V, right. Now you can apply principle of homogeneity, just B by T is equal to L by T. So B is equal to L. We have to take this principle of homogeneity. It's very clear, we are going to take this one. Yeah, you have to apply this. We are considering the principle of homogeneity at each and every step, then we will solve this problem. Just you have to take this one and you can solve the problems, right. Please take this one. what we have obtained, just we can recap. So C is equal to T, C is equal to T, capital T, just we have to take in that, since T, okay, all right. Now we are going to take that, yeah, here what we have obtained that, yeah, B by T plus T is equal to V, all right. These are going to be having that same, yeah, therefore B by T is equal to L by T, just you can take that B is equal to L. So if you are comparing that, third option is the correct one. So B is equal to L, just you have to take this one, this is going to be equated, all right. That's what you can solve the problem for any given relation by applying the principle of homogeneity. It is very clear. That's what we are comparing this one, we have obtained this one, right. Added, if, just you have to take this one, if C and T are equal, same nature, just you have to write C and T are having the same nature, they are having that same kind. So if they are going to be same kind, then it is possible to get that addition. Similar quantities are going to be added, yes. Dissimilar quantities, if they are going to take the two dissimilar quantities, you can't get that addition, then only you will express in the form of addition. It's very clear, we have solved this problem. First of all, it is very clear. After that, we have taken and we have compared, that is simply you will write that is equal to L by T, right. You can take this one individual part and solve this problem. It's very clear. Let's go for another one. Just we have to take that, yeah, effect of temperature on volume. As the temperature increases, the volume is also going to be increases, you have to take this one. So it's going to be raised, all right. What happened, let's see that. What happened if you are going to take that pressure and volume, right, right, you have to take that, decreasing the volume, increasing the collisions and increasing the pressure. So if you are going to take that P and V, they are going to having that is one relation, they are going to have one relation, that is, yeah, PV is equal to constant, yeah, right. Now you will take that the inverse variation, it's very clear. Therefore P1 V1 is equal to P2 V2. As that you are going to talk about that variation of pressure, then what is the volume, what is the effect on this volume? Here you will identify that P is, yeah, you can take this one, this, yeah, you are going to take that inverse variation as P1 by P2 is equal to V2 by V1, right. If you are going to take that this inverse relation, what happened as the pressure increases, what about that volume, it's going to be decreases, yeah. You can take that inverse, yeah, it is going to be inversely, varying inversely, right. You can take that, you can represent in the form of graph also, as you take that, just you will take that volume and pressure, you have to get this one. Yeah, you are going to identify that as the P increases, what happened? Volume is going to be decreases, right? You can take that at that, yes, you will get this one, right? It's going to be taken as that increasing. You will find out this graph. So, we are going to take that problem based on this one, right? Van der Waals gas equation that gives the relation, pressure, please take this. Yeah, this is the pressure, this is the volume, this is the temperature, or is the real gas constant. Now, if you are going to get that Van der Waals equation, it is used to represents the variation of pressure with the temperature and variation of volume with respect to the temperature and pressure. That is very clear. It is a one derived equation. Okay. What about that constant which can balance that? We are going to take that A, B are constants. A and B are constants. You have to take that P, it's going to be pressure. All right. Now you are taking that V is the volume. V is the volume and R is the real gas constant. Just you have to take this one, and T is the absolute temperature. It's very clear. And A and B are going to be constant term. It's going to be constant term. It is going to be one constant term in order to get that balanced state. Yeah, that is the purpose what they have been introduced in order to get that balanced condition. Just they are going to get having that additive terms, and B is also constant term. All right. Okay. Just you have to take this one. These two are not at all related. Just you have to take that. Right. It represents energy, simply RT term that is going to give that energy. Okay, you have to take that pressure and volume. What they are going to ask that? In Van der Waals equation, the dimensions of A and A by B, the dimensions of A by B are as. Just you have to solve this problem. That is the question. All right, you have to take that one. Yeah, take this equation, right? This is the given equation. This is the term. This is also one term. So there exists a addition here and here subtraction. You are all getting that addition of the terms and subtraction of the terms. They are also having the same kind. If you are going to take that principle of homogeneity, already we have discussed about this. All right. Now you are going to get the problem solvation, right? By applying that, the principle of homogeneity. Homogeneity. We can solve that A and B. By applying the principle of homogeneity, we will get that A and B. It is very clear. That is what you are going to take that the individual terms and we will solve that. Right. Now, we are going to take that P plus A by V square. You are taking that, yeah, P plus A by V square. So, these are all going to be P is equal to A by V square. They are also having the same nature. They are also having the same nature, kind, that is of, right. Just you have to compare, just you have to equate that. That is very clear. You have to take that. This is very clear. Now, if you are going to take that dimensional formula, that is, we know very well about that, pressure P is equal to force by area. Area, very clear. Pressure P is equal to force by area. So, you know that dimensional formula for pressure mLT minus 2. Already we have discussed. Area is going to be L square. So, V is volume. That is V square is equal, V is equal to, just we have to take this one, is equal to L cube. Just you have to put in that equation, yeah, you should get that mLT minus 2 by L square is equal to A by L cube whole power 2. Alright, that implies the mLT minus 2 L power 6 by L square is equal to A. Alright, just you have to take that m L power 5 T power minus 2 is equal to A. Alright, it is very clear. Now, you are getting that V is equal to B, that is L cube is equal to B. Therefore, your aim is A by B, just you have to get this, you have to get this one, right. You are going to get the, therefore, A by B is equal to m L power 5 T minus 2 whole upon, that is L cube. Now, you are getting that cancellation to, just we have to take this one. So, that is equal to m L square T minus 2. You are getting the final answer, that is, you can take, once again you can observe all these things what we have applied. We have been started by applying the principle of homogeneity and we have taken individual terms and we are going to be equated that one. We are going to be equated that V is equal to B and P is equal to A by V square by satisfying the condition principle of homogeneity. Alright, we have obtained the dimensional formula for pressure, that is force by area, and final expression is there. Therefore, A by B is equal to m L square T minus 2. This is for energy, you are going to take that energy. Yeah, you will take that energy, that is m V square, like you will take that kinetic energy or potential energy, that is m L by T whole square, that is m L square T minus 2. Very clear. We are going to get the answer, this is the energy, this is the expression for energy. Alright. So, just you can solve this kind of problems by applying the principle of homogeneity. Alright. Okay students, thank you very much, have the nice day and convey to all your friends about this App Master Foundation.